In this question, we have to evaluate the given determinants. So we have been given these four determinants and we have to calculate their respective values. Okay, now to solve those determinants, we should know the expansion of the determinant of order 3. Okay, so I give you a brief about how we expand the determinant of order 3. Now consider that we have a determinant a11, a12, a13, a21, a22, a23, a31, a32, a33. This is the determinant of order 3 which we have taken. And we wish that we have to expand this determinant along the second row, that is R2. This is the second row and we are going to expand this determinant about this row. Okay. Now, the expansion about any row or any column can be done for a given determinant, and the method is same for the expansion of any row or any column. Okay, so how we expand a determinant about the second row? So the expansion is equal to, first we take the element which is in the second row, that is the first element of the second row, that is the element which is located in second row and the first column, that is a21. Okay, this is multiplied by minus 1 to the power of 2 plus 1, that is the location, that is second row and first column. And further it is multiplied by the determinant of second order, which is obtained by removing the row and the column of that element. Okay, so because the element 21 is in second row and the first column, so we are left with these four elements a12, a13, a32 and a33. Okay, so this will be the first term. Second, what we are going to do, we are going to take a22, that is the next element of the second row, multiplied by minus 1 to the power of 2 plus 2, that is because the element is placed in second row, second column, into the determinant obtained by removing the second row and the second column. So this will be equal to a11, a13, a31, a33. And the third term would be a23, that is the element, that is the third element of the second row, into minus 1 to the power of 2 plus 3, because the element is located in the second row and the third column. Okay, and into the determinant which is obtained by removing the second row and the third column, that is a11, a12, a31, a32. Now we know that how we are going to solve this determinant of order 2, and we have to just simplify to get the value of this determinant. Okay, so this is how we are going to expand the determinant to solve the value of determinant of order 3. Okay, so for the first part, I have been given the determinant 3 minus 1 minus 2, 0 0 minus 1, 3 minus 5 0. Okay, so first thing what I observe here is this, that in the second row I have two zeros. So always make it a point, we are going to expand a determinant about such a row or a column which have maximum number of zeros. So the second row has maximum number of 2 zeros, so we are going to expand it along the second row. So we are going to expand this determinant along the second row. So this will be equal to the first element 0 into minus 1 to the power of 2 plus 1, because this element is located in second row and first column, into the determinant obtained by removing the second row and the first column. So we will be left with minus 1 minus 2 minus 5 0. Okay, second term would be 0 into minus 1 to the power of 2 plus 2. Okay, because this element is in second row, second column, into the determinant obtained by removing the second row and the second column, that is 3 minus 2, 3 0. Okay, plus minus 1 time, that is the element which is, that is the third element of the second row, into minus 1 to the power of 2 plus 3, because this is located in second row and third column. Okay, into the determinant obtained by removing the second row and the third column, that is 3 minus 1, 3 minus 5. Okay, so it's quite clear that 0 into any number is 0, so we are going to get this whole thing as 0, this whole thing as 0. And the third term would be equal to minus 1. This minus 1 is raised to the power of 2 plus 3, that is an odd number, so it will be minus, into minus 15, minus sign, into minus 3, right? So this minus and minus will become plus. This will be equal to minus 15 plus 3, that will be equal to 12. Okay, so that will be equal to minus 12, sorry. Okay, so minus 12 would be the answer of this determinant. Okay. In the second part, I have been given the determinant 3 minus 4, 5, 1, 1 minus 2, and 2, 3 minus 1. So this can be expanded about any row or any column, because I don't have any preference about the values with which I could expand. So generally I expand about the first row. So expanding along the first row, that is R1, this is the first row. So first term would be the first element of the first row 3 into minus 1 to the power of 1 plus 1, because this element is located in first row and first column, into the determinant obtained by removing the first row and the first column, that is 1, minus 2, 3 and 1. Okay. Next it would be minus 4, that is the second element of the first row, into minus 1 to the power of 1 plus 2, into the determinant obtained by removing the first row and the second column, that is 1, 2, minus 2, 1. Okay, and plus 5 times 5 into minus 1 to the power of 1 plus 3, because this element is located in first row and third column, into the determinant obtained by removing the first row and the third column. So I'm going to get 1, 1, 2, 3. So this will be equal to, first of all, this term is going to solve and give us a plus sign. Okay, so I'm going to get 3 into 1 into 1 is 1. Minus sign would be there, but here it is minus 6, so I'm going to get plus 6. Okay, this term would be minus, so I'm going to have a minus sign in between. Further, 1 into 1 is 1, and 2 into minus 2 is minus 4, and we place a minus sign in between, so I'm going to get minus minus plus 4 here. And this will be equal to plus, because minus 1 to the power of 1 plus 3 is minus 1 raised to the power of an even value, so this will be equal to 5. This will be equal to a plus sign. Further, I'm going to get 5 into 3 minus 2. So this will be equal to 21 on solving, plus 20 plus 5, that will be equal to 46. So 46 is the value of this determinant.